Alright, here we are. Alright, hey guys, it's Miss Scott with another video on genetics and exceptions to Mendel's rules. Today we're going to talk about codominance. Let's start by talking about what that means. When we say codominance, in codominant traits, both alleles to both versions of the trait are dominant. In the last video I made, incomplete dominance, we said that neither allele is fully dominant. Here they are both dominant. And how that differs in incomplete dominance, in heterozygotes here, both phenotypes are expressed. In incomplete dominance, you have this in-between mixing, blending with the heterozygous phenotype. Here we just show both of them at once. And if you need an image of what that looks like in your brain, pretend this is a black marker. If you take a chicken, that's a chicken. Yeah, we'll say that's a chicken. You take a chicken that has black feathers and cross it with a chicken that has white feathers. You end up with a chicken, instead of having gray feathers, which would be the in between, you get a chicken that has some black feathers and some white feathers. This, by the way, in case you're curious, is called a checkered chicken if you want to look that up on Google as to what that looks like. A good example of codominance. The key word that we're going to use for codominance, that stem co means together. Like if you cooperate with somebody, you're working with them, or if you cohabitate, you live together, something like that. So that's the word we're going to remember. Incomplete was in between or intermediate, co, together. So let's look at some practice problems. Keyword together. Yay. All right, let's zoom out just a little bit so you can see everything. There we go. All right. So some common examples that you're going to see in my class involve this particular trait of fur color in livestock like cows or horses. So in horses, chestnut or brown hair is codominant to white hair. So horses with a mixture of chestnut and white hair are called roan. So if you were to look at a roan horse up close, you would see some of their hair is brown, some of it is white. Cross a roan horse with a chestnut horse. Show your work. So the first thing we're going to do, we're going to set up the parent alleles like we do for all of them. With codominant, I use different letters to show different alleles, but they're both use different letters. So I will use different capital letters to show white and brown. So I will use W for white, B for brown. You could use C for chestnut too. It doesn't really matter as long as you know what it means. So here we have a roan horse. We know roan has chestnut and white, so I'll put B and W. And a chestnut horse. Well, if it's chestnut, it only has the alleles for this brown hair. So that's what I will put. Let's cross it, show our work. This B will drop here and come over. So 2 B's there. B, W, B, and B, and another B and W. If these two horses are crossed, 50% of the offspring will be. So we see there's 2 and 2, 50% of them. These offspring will be chestnut or brown, whatever you want to call it. And these two, much like this parent, who has one of each allele, will be roan, where they have both brown hair and white hair. Let's look at this second problem while we have it here. Calico cats are a product of codominance. When an orange cat and a white cat mate, they produce a calico cat. Make a Punnett square. So again, assign your different letters. I'm going to say O is for orange, W for white, and let's see what we end up with. To get a calico cat, you would need one of each allele. Calico. All right. So we want, when an orange cat and a white cat mate, they produce calico. Use the Punnett square to show this. Okay, so let's take an orange cat, 2 O alleles, and a white cat, 2 W alleles. Again, just like with incomplete dominance, just like with complete dominance, if you have 2 homozygous individuals, but they're different from one another, homozygous for orange, homozygous for white, all of your offspring are going to be heterozygotes. They will have 1 of each allele. This parent, let's say this is the female cat, is only donating the orange allele. This cat, the male cat, is only donating the W allele. So you have 100% heterozygotes that have both phenotypes, in this case calico. Okay. If you have any questions about codominance or how it differs from incomplete dominance or where you can get more practice, leave me a comment and I will get back to you as soon as humanly possible. Have a super awesome day.